Level 0. It surrounds you every second. The quiet hum of the universe. You don't feel it, you don't see it, but your body absorbs it, step by step, breath by breath. This is background radiation. Cosmic rays streak in from space. Fragments of ancient stars smash into the upper atmosphere, creating cascades of secondary particles that rain on you daily. Gamma rays from the Milky Way pass through your skull. Some particles burrow into DNA, leaving invisible scars that may never show. From below, the ground leaks its own signature. Radon gas seeps from uranium-rich rock. Granite countertops emit tiny radioactive particles. Even the bricks in your house carry a geologic fingerprint from when Earth formed 4.5 billion years ago. Your body holds its own radioactivity. Potassium-40, carbon-14, isotopes born in stars, now locked in your cells. Every second, atoms in your bones decay, releasing radiation that leaves no wound. You are both a victim and source. Numbers bring perspective. The global average, 2.4 millisieverts per year, higher if you live in mountains, lower at sea level. A long flight above the clouds adds about 0.03 millisieverts. Cosmic rays slipping through thin air at cruising altitude, a dose carried silently with every mile across the sky. A chest X-ray, 0.1, yet the body tolerates it all, adapting across generations. Bananas, famous for their potassium, are used as a joke measurement, the banana equivalent dose. Eat one, and you gain 0.1 microsieverts. Millions would be required to hurt you. But it proves the point. Radiation isn't foreign. It's life's constant shadow. In Ramsar, Iran, natural hot springs seep radium into the soil, and some homes bathe in doses far beyond the world's norm. Dozens, even hundreds of times higher in rare spots. Yet across the population, the story is murkier. Studies show no clear rise in cancer, only questions science still wrestles with. Nature hints at resilience, and at mysteries science still doesn't fully understand. Background radiation isn't a threat. It's context, the baseline of existence. Every other level rises from here. Level 1, the longest wavelength, the lowest energy. Not killers, messengers. They stretch across the planet like invisible rivers. AM broadcasts, FM songs, GPS signals, radio waves link satellites in orbit with antennas on Earth, carrying voices across oceans in fractions of a second. Discovered in the late 19th century by Heinrich Hertz, they proved James Clerk Maxwell's equations right, and they changed civilization forever. One band built global communication, another guided ship at sea, another mapped planet with radar pulses bouncing off alien landscapes. Radio waves are non-ionizing radiation. Their energy is too low to break chemical bonds or damage DNA. That's why you can fall asleep next to a radio and wake up unharmed. But power still matters. In massive doses, they burn. The US military tested active denial systems, focused microwave beams that heated skin, driving crowds back without bullets. It worked. Volunteers described pain like touching a hot iron, without permanent harm. Invisible fire projected at will. Astronomy depends on them. Radio telescopes like Arecibo, before its collapse, listened to faint whispers of hydrogen from the edges of galaxies. The cosmic microwave background, radiation from the birth of the universe, is picked up as faint static in every old TV antenna. From the kitchen clock to deep space exploration, radio waves prove that radiation isn't always destruction. Sometimes it's the foundation of civilization. Level 2, microwaves. Shorter than radio, stronger, focused, they change the ordinary into the extraordinary. At home, they vibrate water molecules. That vibration becomes heat. Dinner ready in minutes. The magnetron, a World War II invention designed for radar, gave birth to the microwave oven, an accident that reshaped kitchens worldwide. But microwaves extend far beyond reheating leftovers. They guide planes through storms. They link Wi-Fi routers, bouncing signals invisibly through walls. They paint the inside of hurricanes for Doppler radar, still non-ionizing, still too weak to snap DNA. But focused into high beams, they become dangerous. Exposure at close range burns skin. Experiments show microwaves can superheat tissues, boiling eyes, or organs silently. The Cold War whispered darker stories. The Moscow signal, US embassy workers in the Soviet Union exposed to directed microwaves for decades. The true intent remains classified. Espionage, weapon, test, no answers, only suspicion. Microwaves also probe worlds beyond Earth. In 1992, the Cosmic Background Explorer mapped faint microwave radiation across the universe. It revealed patterns left from the Big Bang itself, proof that our universe once blazed as fire before cooling into stars. From popcorn to cosmology, microwaves sit between comfort and danger. Radiation that cooks food, reveals storms, and whispers secrets of the cosmos. Level 3. The heat you feel but cannot see. Step into sunlight, stand by a fire, touch another person's hand. Infrared radiates in every exchange of warmth. Every object above absolute zero emits it. Rocks, clouds, animals. Your skin glows in the infrared, unseen but measurable. It is harnessed everywhere. Remote controls send pulses of infrared light across living rooms. Night vision goggles translate it into green ghosts on a soldier's screen. Infrared cameras in airports detect fevers, scanning thousands at once. It shapes science. Astronomers use it to pierce cosmic dust. The James Webb Space Telescope sees stars forming inside clouds, opaque to visible light. Infrared revealed the oldest galaxies ever observed, light stretched by 13 billion years of cosmic expansion. Mostly harmless, but intensity matters. Lasers tuned to infrared can cut steel. Industrial furnaces radiate infrared strong enough to sear flesh instantly. Heat lamps that warm food in restaurants? The same radiation, controlled. Infrared sits at the edge of the visible spectrum, close enough to be familiar, strong enough to reshape industries and rewrite astronomy. Level 4. Visible light. The sliver humans see, a rainbow carved into 7 colors: red, orange, yellow, green, blue, indigo, violet. But this is only a fraction of radiation. Visible light fuels photosynthesis. Plants capture photons, splitting water and forging glucose, the base of Earth's food web, powered by radiation from 93 million miles away. It builds civilizations. Solar panels turn light into electricity. Fiber optic cables fire lasers down glass threads, carrying internet across continents at the speed of light. But beauty holds danger. Lasers, concentrated visible light, burn skin, ignite wood, blind eyes instantly. Industrial lasers slice through titanium with surgical precision. Even a pocket laser pointer can blind a pilot, forcing planes to reroute. History carries strange echoes. In 212 BCE, legend says Archimedes used mirrors to focus sunlight and set Roman ships ablaze. Whether myth or truth, the principle is real. Concentrated light is power. The sun delivers 173,000 terawatts of visible light energy to Earth at any moment, more than all humanity consumes in a year. Harnessed, it could power civilizations. Ignored, it burns deserts and fuels the climate itself. Light isn't gentle, it's survival. Level 5. Ultraviolet radiation, UV. The invisible killer at the edge of sight. Shorter wavelength, higher energy, enough to break DNA, enough to mutate cells. Stand too long in sunlight, skin reddens, cells rupture, mutations accumulate, cancer follows. Earth's ozone layer shields us from most UV, but the thinning of ozone in the late 20th century revealed its importance. In Antarctica, a hole opened in the sky, and ultraviolet light poured through with punishing force. The world took notice, worried for skin, for crops, for futures. And nations united to heal the ozone, proof that humanity can patch the sky when survival demands it. Governments banned chlorofluorocarbons, chemicals eating the ozone. The world united, and the ozone began to heal. But UV is not only a destroyer, it sterilizes. Hospitals use UV lamps to disinfect surgical tools. Water treatment plants use it to kill pathogens without chemicals. UV marks banknotes, invisible until revealed by scanners. Astronomy adds another role. The Hubble Space Telescope captures ultraviolet light from galaxies billions of light years away, showing star clusters blazing hotter than suns. Yet the most human story remains simple: teenagers chasing a tan in salons, artificial UV bulbs bathing skin in radiation thousands of times stronger than sunlight. Decades later, scars of melanoma. Ultraviolet is proof that radiation doesn't just illuminate, It mutates. It punishes those who forget its power. Level 6. X-rays, radiation that sees through flesh. Discovered in 1895 by Wilhelm Röntgen, he called them X because their nature was unknown. Within weeks, scientists captured the first image of a human hand, bones glowing white beneath translucent skin. It shocked the world. Hospitals embraced it instantly. For the first time, doctors saw bullets lodged in bodies, fractures hidden beneath flesh, teeth rotting inside gums. X-rays rewrote medicine, but they carried a price. Early pioneers exposed themselves daily. Radiation burns scarred their hands. Cancer followed. Marie Curie herself, who studied radioactive elements, died from aplastic anemia caused by years of exposure. X-rays are ionizing, each photon strong enough to knock electrons from atoms, breaking chemical bonds. DNA suffers the blows. Cells mutate. Cancer grows. Still, controlled doses save lives. CT scans map tumors. Dentists find cavities. Security scanners uncover weapons at airports. The risk is measured against necessity. Industrial uses expand further. X-rays test airplane wings for microscopic cracks. They scan cargo ships for contraband. They even analyze ancient scrolls, revealing text hidden beneath centuries of ash and carbon. Astronomers use X-ray telescopes to watch black holes feed, matter spiraling at near light speed. The cosmos glows in X-rays from neutron stars, pulsars, and supernovae, a violent universe invisible to human eyes. On Earth, exposure is balanced by shielding, lead aprons, concrete walls, strict limits. Because unlike visible light or microwaves, X-rays don't just pass, they scar. X-rays remind us of radiation's paradox. The same force that saves millions in hospitals has also cost countless lives to those who first uncovered its secrets. Level 7. Gamma rays. The shortest waves, the highest energy, invisible bullets of light, each photon a warhead. Gamma rays are born in the hearts of stars, in the collapse of supernovae, in the decay of radioactive elements. They slice through flesh, through steel, through anything in their path. In medicine, they cure and they kill. Doctors aim gamma beams at tumors. Cells mutate, DNA shatters, cancer dies, but healthy tissue suffers too. A balance between healing and harm. In 1986, the Chernobyl disaster proved their fury. Firefighters raced toward the burning reactor. Gamma radiation bathed them, skin reddened, bone marrow failed. They absorbed in minutes what no body could endure in a lifetime. Some died within days. Gamma rays also unlock mysteries. NASA's Fermi telescope captures flashes of them from deep space. Every burst a message from violent events billions of years away, collapsing stars, merging neutron stars, black holes feeding, a violent universe written in radiation. Gamma rays cannot be seen, but their mark is everywhere. They sterilize food. They reveal cracks in steel beams. They erase bacteria from medical tools, but unshielded, they make the human body unravel cell by cell. Lead walls block them. Concrete absorbs them, yet no shield is perfect. Gamma rays remind us that light itself can become a weapon. Level 8. Cosmic rays. Not light, particles. High-energy fragments of atoms traveling at near light speed. Protons, helium nuclei. Iron cores ripped from supernovae, crossing galaxies, slamming into Earth's atmosphere with the energy of thrown baseballs condensed into subatomic scale. When they strike, they unleash showers. A single cosmic ray can collide with an air molecule, splitting it into cascades of pions, muons, electrons. A storm of radiation rains down. Billions pass through your body every day. Harmless in small numbers, devastating in large doses. In 1912, Victor Hess carried an electroscope in a hot air balloon. The higher he climbed, the stronger the radiation. Proof that space bombards us constantly. He had discovered cosmic rays. They complicate life in space. Astronauts beyond Earth's magnetic shield are targets. The Apollo mission saw flashes of light when eyes were closed, cosmic rays striking retinas. On a mission to Mars, astronauts could receive doses high enough to double cancer risk. Cosmic rays also change Earth itself. They strike nitrogen in the atmosphere, creating carbon-14. That isotope seeps into plants, animals, bones. It is the clock of radiocarbon dating, allowing scientists to measure the ages of ancient artifacts. Some rays carry unimaginable energy. The "oh my god" particle, detected in 1991, struck with the force of a baseball pitch packed into a single proton. No accelerator on Earth could match it. Its origin still unknown. Cosmic rays are the universe's bullets. Relentless, silent, proof that space itself is hostile. Level 9. Neutrinos. Radiation stranger than light, stranger than particles. Ghosts of the universe. Billions pass through you every second. Through walls, through Earth, through oceans. Almost nothing stops them. They are born in nuclear reactions. The sun's core fuses hydrogen, producing light, heat, and endless streams of neutrinos. Supernovae unleash floods of them, billions of billions, in a single burst. Nuclear reactors on Earth spill them constantly. For decades, neutrinos seemed impossible to detect. Too slippery, too indifferent to matter. But in 1968, Raymond Davis built a tank of cleaning fluid buried deep in a South Dakota mine. Once every few days, a neutrino struck an atom. Proof they existed. Now, giant detectors catch them in Antarctic ice, in underground pools, in mountain caverns. They are windows into the core of stars, into the past of the universe itself. They carry almost no mass, but they carry information. A neutrino from the sun takes 8 minutes to reach Earth. A message from fusion at the heart of a star. A flood of neutrinos reached Earth hours before visible light from supernova 1987A. A cosmic warning bell ringing in advance. Neutrinos cannot burn you. They cannot mutate DNA. But their value is different. They whisper secrets no other radiation can reveal. Ghosts of the cosmos that pass through flesh and stone as if neither exist. Level 10. Nuclear fallout. Radiation born not in stars, not in space, but in human hands. July 16, 1945. Trinity test, New Mexico desert. The first nuclear bomb explodes. Light brighter than the sun. A mushroom cloud rising 40,000 feet. And in its ash, fallout. Particles of uranium, plutonium, cesium, strontium, carried by winds, falling back as invisible poison. Hiroshima, Nagasaki. Gamma rays and neutrons struck in the first second, killing tens of thousands instantly. But fallout lingered. It contaminated soil, water, generations. Cancer rates soared for decades. In 1954, Castle Bravo, the largest U.S. nuclear test in the Pacific. The bomb was miscalculated, its yield twice as expected. Fallout rained on islands 100 miles away. Villagers developed radiation sickness. A Japanese fishing crew, Lucky Dragon 5, contaminated by ash, became symbols of nuclear horror. Fallout spreads unpredictably. Wind carries it, rain concentrates it, crops soak it in, milk passes it to children, invisible, tasteless, lethal. It is why nuclear accidents haunt us. Chernobyl, 1986. Fukushima, 2011. Not just explosions, but the dust and isotopes carried for centuries. Cesium-137 has a half-life of 30 years. Strontium-90 lodges in bones, mimicking calcium. Plutonium remains toxic for 24,000 years. Fallout is not just destruction in the moment, it is inheritance, a legacy written in isotopes that outlive civilizations. Level 11. Space radiation. Beyond Earth's shield, radiation reigns. The magnetosphere deflects most cosmic rays. The atmosphere absorbs solar storms, but in orbit, astronauts face a different world. The International Space Station circles inside partial protection, yet astronauts receive about 20 times Earth's background dose. Cells mutate faster, immune systems weaken, cataracts form early. Beyond that, the risk grows. A single solar flare can bathe spacecraft in charged particles. The 1989 storm knocked out power to Quebec, but in space, it could have killed crews unshielded. During Apollo missions, luck mattered. No major solar storm struck while astronauts walked on the moon. Had one erupted, they would have died in days. Future missions to Mars face the greatest threat. A round trip could expose crews to doses far beyond safe limits. Radiation shielding in spacecraft is heavy, too heavy for long voyages. New technologies, magnetic fields, water shielding, even underground Martian bases may be required to keep humanity alive. Radiation is the true barrier of space travel. Not distance, not fuel, but invisible particles slamming through flesh, rewriting DNA. Earth's shield is fragile. Step outside it, and survival becomes a countdown. Level 12. Gamma-ray bursts. The ultimate radiation. The brightest explosions in the universe. Gamma-ray bursts. Born when massive stars collapse into black holes, or when neutron stars crash together. For seconds, they outshine entire galaxies. Beams of gamma rays stretch across billions of light years. If one pointed at Earth, it could strip away the ozone in minutes, expose the surface to lethal ultraviolet, trigger mass extinctions. Astronomers believe one may have already struck Earth. 450 million years ago, during the Ordovician extinction, life in the oceans collapsed. Some scientists suggest a gamma-ray burst bathed Earth, collapsing food chains and freezing seas. The evidence is circumstantial, but the possibility is terrifying. In 2004, a magnetar in our own galaxy erupted. Its gamma rays struck Earth's atmosphere 50,000 light-years away. Satellites were blinded. Radiation spiked. Had it been closer, the ozone would have vanished. Gamma-ray bursts are the universe's snipers. Random, distant, unstoppable. No shield, no warning, no defense. They are the full stop at the end of radiation's story, from the warmth of infrared to the extinction-level blasts of the cosmos. A spectrum that begins with life and ends with silence. With this, we come to the end of our video. Thanks for watching, and see you in the next one.